Hey, it's me again. Today we're going to talk about acid-base chemistry and how do we know if something's an acid or a base? And we'll talk about what the definitions of that means. But we're going to look at something that are called indicators. So indicators are chemicals that will change color depending upon the presence of different kinds of hydrogen ions and how many there are. And so we'll start with some really simple ones. This is red litmus paper. Red litmus paper will turn blue in the presence of a base. If it's neutral or an acid, it won't do anything. Blue litmus paper will turn red in the presence of an acid. And then I have a couple more that are more specialized pH paper, and they have a whole range of colors that they'll go from neutral, which is the color of the paper, is yellow, and then bases will be dark blue, acids will be bright pink. This is another one called a rainbow acid indicator, and it measures from a range of pH from 1 to 7. And this is something called bromothiamyl blue, and it's very specific for a particular range, and it only goes from the range of 6 to 7.6. So if it's a pH of 6 or below, that's acidic, then it'll turn yellow. If it's 7.6 or above, then it will be blue, and it's kind of a blue color. This is a universal indicator, and it has a wider range. And you can see all of those color choices. And so we're going to actually be using that one in just a minute. It goes from a pH of 4 to 10. So if something's a lower pH, it'll just go with whatever the lower color is. In this case, it's red. If it's a higher pH, it'll go with the dark purple color, which is above 10. And so remember, the scale goes from 0 to 14. If it's 7, that's neutral, like distilled or deionized water. If it is below 7, that's acidic. And if it's above 7, that is basic. And this is phenolphthalein. Phenolphthalein actually is kind of weird. It'll turn bright magenta. I'm still here. So what we have is I have this well plate where I have put samples of hydrochloric acid here, and which is obviously a strong acid. And then I put acetic acid, which is also vinegar, the main ingredient in vinegar, which is not as strong of an acid. And then I put water, which hopefully will be neutral on the pH scale. And then I put some sodium hydroxide, which is for sure a strong base. So I'm going to test it in a variety of different ways so you can see what these indicators do. So here's some red litmus paper. It should turn red in the presence of, it should turn blue in the presence of a base. Sodium hydroxide, strong base. Water, nothing happening. Acetic acid, it's an acid, stays red. Hydrochloric acid, acid stays red. All right, so let's try the base, or let's try the blue litmus paper. So that stays blue in the presence of a base. Water is neutral, should stay blue as well. Acetic acid is an acid, so it's turning red or pink, as you can see, I hope. And HCl. So, all right, so both of those appear to be acidic, which is what I thought all along. And so now I'm going to use a different pH scale. It has different colors all the way from 1 to 12. So you can kind of see those colors. So the reddish pink is the most acidic. So let's test the NaOH, which I anticipate to be a base. I hope you're anticipating. All right, so if I match that up with the paper, it seems to be 12, or it could be above 12 because if it's a strong enough base. Let's look at H2O. I hope that H2O will be neutral, or this is some really bad water. It's pretty yellow. That matches up with the pH over here, so it's what I expect. If I don't get what I expect, it probably means my well plate is dirty and I need to try again. So let's try acetic acid. All right, that's kind of an orangish pink. So it's got a pH of around 3, it looks like here. And let's try hydrochloric acid. Hydrochloric acid, much brighter color. That's a pH of 1 or less. Okay, so let's try some bromothiamyl blue. That only measures a range of 6 to 7.6. So let's see if the sodium, okay, that means it's above 7. Water is somewhere in between. It's a little bit greenish blue. All right. Oh, this means it's pH of below 6. Also a pH of below 6. So that was bromothymol blue. Remember, there's lots of different indicators. Now let's try some phenolphthalein. It turns bright pink if something is basic. So we'll start here. This acid, nothing happens. This acid, nothing happens. Water, nothing happens. Base turns a lovely magenta color. And now we have universal indicator. And it goes on a scale of 4 to 10. So if it's purple, it means it's above 10. If it's bright red, it means it's at least 4 or below. So let's start it with our acid. There's my hydrochloric acid. There's my acetic acid. That means they're both 4 or below 4. Here's my water. Yay, it's green. It should be. And here is my base. That is definitely a dark purple color. So there's some acid-base chemistry for you, and some really great colors as well. Hello again. One more demonstration involving acid-base indicators. And so I'm going to use some vinegar or acetic acid. I'm going to mostly fill up this beaker right here. This test tube from this beaker. So this is acetic acid or vinegar. So it is a relatively weak acid, kind of medium. And then I'm going to put in a lot of this universal indicator, which I put the scale for right here. So this is green if something is neutral. Well, so this is not neutral. Whoa. Also, I see that the indicator is actually a little bit less dense, and so it just has a tendency to just sit there. I need it to go all the way down, so maybe I'll stir it just a little bit. And I'll spill it as well. Just ignore the spilling for now. Now I have room for some more indicator. Add a little bit more. I'm just doing it to make the colors a little bit more vibrant. So I have this thing that is obviously acid, and now I'm going to add some pretty concentrated sodium hydroxide, which is a base. This is a pretty concentrated solution, so it's actually a little bit more dense. And so you might be able to see it running down the side of the beaker, or the side of the inside of the test tube. So you see it is traveling down to the bottom. And because it's very basic, it's turning the solution blue at the bottom. And if I were to stir this up a little bit, I'll just spill some more, what the heck. If I would stir this up a little bit more, you would see what it looks like at the bottom. And eventually, if I let it sit for long enough, you'll end up with this nice little rainbow that has a pH of colors. So at the very bottom, it's kind of a blue-green, and then it kind of transitions up into a yellow and a more orange color, and then it is a red color indicating an acid because the more dense base has sunk to the bottom, and that allows the colors to separate a little bit. Thanks a lot.